Okay, this video will talk through what I call tricky problems or expressions that differ by a -1. So an example like number 1, you can see that the binomials are almost identical, but the order is reversed and the operation connecting them is subtraction. So I could look at this as my numerator is x minus 9. If I were to factor a -1 out of the denominator, that would leave me with -9 plus x. And if I wrote that or changed that order, that would leave me with x minus 9 and the -1. Just verify that those are exactly the same. And then that would enable me to then divide out x minus 9 on top, x minus 9 on bottom, and my simplified answer would just be -1. Differing by that factor of -1, but simplified down to -1. Let's look at number 2 together. And this is an important skill when you're working with rational expressions. It's important to be able to recognize this and know how to handle it. So something like number 2, and once you recognize that it's coming, then it makes it easier for you to prevent yourself from being confused, because you can factor and set it up so that it's easy at the during the second step. So here I'm going to copy x plus 5, and I see that I've got this x minus 5 here. If I go ahead and factor out a -1 and turn this into x squared minus 25, then it's going to make it a little bit easier for me on the next step. And I copy this, and note that 5 plus x and x plus 5 are the same because addition commutes. And now in my next step, well, I guess I can go ahead here and divide these out, and then I'm left with this. I've got x minus 5, and then my denominator, I've got the -1, and I'm going to factor this now as x plus 5, x minus 5. And I forgot to list my excluded values, but my excluded values for this problem would be both positive and -5. Those would be my domain restrictions. And now this enables me to divide out x minus 5 on top, x minus 5 on bottom, and now my simplified answer would be 1 in my numerator. Remember, when everything divides out of the problem, a positive 1 is left over, and I pick up the factor of x plus 5 in my denominator, but I have this negative sign, so I'm just going to go ahead and write it flush with the fraction bar so that this becomes my simplified answer. Let's see what happens whenever you're adding. And when you're adding fractions, you have to have a common denominator. So in something like number 4, if I say that my LCD is x minus 3, I would take the first expression and just copy that as x minus 3. And then I would have the second fraction. And if I think of introducing that -1 sign into that denominator in order to give it the LCD, what this does really is it just simply changes the operation between the two fractions by introducing that negative sign. So I end up with 4 over x minus 3, and instead of adding these together, that becomes a subtraction operation between the two expressions now, and I just simply copy the second expression as it was, but I write it now with that common denominator. And so now I can combine the numerators, and I would have 4 minus 2 over x minus 3, and that's going to leave me with 2 over x minus 3. So by introducing that negative sign into the problem in order to get the LCD, the way I feel that result is it just simply changes the operation between the two expressions. Let's look at number 5 together. So in number 5, I've got 2x minus 3 and 3x minus 2. If I decide that I'm going to go with the LCD as 2x minus 3, and I see that I've got subtraction between the two expressions, if I introduce an additional negative sign into the problem in order to take the second denominator and reverse the order so that I have like denominators, what it would do is turn my operation into addition. So my LCD is 2x minus 3, and I'm now going to have 7, but I'm going to add 2. I'm going to have 7 plus 2 rather than 7 minus 2. So now my expression is 9 over 2x minus 3. And there are several different ways to think about this, but the end result, the process that I'm going through, the end result is changing the operation between the two expressions to accommodate the negative sign difference between the two original between the two original denominators. And let's look at one more just to show you how fast it goes. Something like number 7. My denominators are differing by that -1 factor again, so I could just say that my LCD is going to be x minus 5, and I've got 3. The original expression is requiring addition, but by introducing that additional -1 sign in order to give a common denominator, it's really going to end up being 3 minus 2 instead of 3 plus 2, and that would simplify down to 1 over x minus 5.